Next topic is inferential analysis. Inferential analysis involves the process of estimating the values of unknown parameters of the population and testing of hypotheses for drawing inferences. So, in inferential analysis, we estimate the values of unknown parameters of the population and we test the hypothesis for drawing inferences. Inferential analysis is also known as statistical analysis. It is mainly on the basis of inferential analysis that the task of interpretation is performed. So, inferential analysis helps to interpret the results of our research study. Statistical inference can be classified into two. First one is estimation of population parameters and second one is test of hypothesis. First one is estimation of population parameters and second one is test of hypothesis. First one, theory of estimation. Theory of estimation refers to the process of throwing some light on the unknown population with the help of sample drawn from it. So we are throwing some light on the unknown population with the help of a sample drawn from it. There are two types of estimates with respect to estimating parameter. They are point estimates. So what is point estimate? If we estimate a parameter with the help of a single value, it is known as point estimate. So if we estimate a parameter with the help of a single value, then we can call it as point estimate. Then what is interval estimate? If we estimate the parameter with the help of a pair of values, then we can call it as interval estimate. And parameter and parameter and statistics. Parameters denote the characteristics of the population, whereas statistics denotes the characteristics of the sample. Okay. The measurement of population, that is what is called parameters. Measurement of sample, that is called statistics. So parameters includes population mean. When we calculate a population mean, then it is called parameter. Population variance, population correlation coefficient. These are all examples of parameter. Statistics include sample mean, sample variance, sample correlation coefficient, etc. So when we make calculations with regard to the population, then the result is called parameter, population mean, etc. And the measurement of sample, that is sample mean, that is called statistic. Testing of hypothesis. A hypothesis is a specific statement of prediction. A hypothesis is a tentative proposition relating to certain phenomenon which the researcher wants to verify when required. It's an assumption or some assumptions to be proved or disproved. It's an assumption or some assumptions to be proved or disproved. What are the steps involved in testing of hypothesis? First step is formulate the null hypothesis H0 and formulate the alternative hypothesis, that is H1. Okay, formulation of null hypothesis and formulation of alternative hypothesis. That is the first step in hypothesis testing. Second one is select the test statistic. Different statistics are there, t-test, then f-test, etc. etc. So select the test statistic. Next step is choose the level of significance. 1% level of significance, 5% level of significance, etc. Fourth one, compute the test statistic. Compute the test statistics. Using the equation, we have to compute the test statistic. Then after that, compare the calculated test statistic to the critical table value of that test for 1% or 5% level of significance. So we have to make a comparison between the calculated test statistic with the table value. T-test or F-test table value is the test table value at 1% or 5% level of significance. Then next step is make decision. If the calculated test statistic is less than the appropriate critical value, accept the null hypothesis. If the calculated value is less than the table value, then accept the null hypothesis. If the calculated value is equal or greater than the appropriate critical value of the test or the table value, appropriate critical value means the table value, then reject the null hypothesis and accept the alternative hypothesis. Rejecting the null hypothesis automatically accepts the alternative hypothesis. Then now type 1 error. What is type 1 error? It is the error committed by rejecting a true null hypothesis. What is type 1 error? Rejecting a null hypothesis when it is true. Type 2 error. It is the error committed by accepting a false null hypothesis. It is an error committed by accepting a false null hypothesis. Degrees of freedom. It means the number of elements that can be chosen freely by the researcher. Number of elements that can be freely chosen by the researcher. So generally it is n minus 1 in the case of simple sample. In the case of a simple sample, the degrees of freedom will be n minus 1. In the case of two sample, it is n1 plus n2 minus 2. Standard error. What is standard error? The standard deviation of the sampling distribution is called standard error. Standard deviation of the sampling distribution is called standard error. Standard deviation is the spread of scores around the average in a single sample. Standard deviation is the spread of scores around the average in a single sample. Standard error, on the other hand, tells us something about how different samples would be distributed. How different samples are distributed. In other words, the standard error is the spread of averages around the average of averages in a sampling distribution. Okay, standard error is the spread of averages around the average of averages in a sampling distribution is called sampling standard error. Types of tests. Statisticians have developed several tests of hypotheses for the purpose of testing hypotheses. They are classified into, tests of hypothesis can be classified into, first one, parametric test, or it is also known as standard test of hypothesis. Second one is non-parametric test or distribution-free test of hypothesis. Non-parametric test or distribution-free test of hypothesis. So parametric tests. The data in this test is derived from interval and ratio measurement. In this case, the data is derived from interval scale or ratio scale. So So different scales that you have already discussed, nominal scale, ratio scale, then interval scale, etc. So in this case, the data is derived from interval scale or ratio measurements. In parametric tests, it is assumed that the data follows normal distribution. Then only we can use parametric test. The distribution should be normally distributed. Examples of parametric tests are Z test, T test, F test. Okay. Non-parametric tests. Non-parametric tests are used to test the hypothesis with nominal and original data. These tests do not make any assumption about the shape of the population distribution. In the case of parametric test, we have some assumptions about the shape of the population distribution, like normally distributed. But in the case of non-parametric test, no such assumptions about the shape of the population distribution. These tests are also called distribution-free tests. Examples of non-parametric tests are binomial test, chi-square test, Mann-Whitney U test, sign test. Then we are going to discuss test one by one. Z test. Z test is based on normal probability distribution. Because it is a parametric test, the test is based on normal probability distribution. It is used for judging the significance of several statistical measures, particularly the mean. Used for judging the significance of several statistical measures, particularly the mean. The test is generally used for comparing the mean of a sample to some hypothesized mean for the population in case of a large sample. It is generally used for comparing the mean of a sample to some hypothesized mean for the population in case of large sample. T test. In the case of small samples, where sample size is less than 30, such sample is called a small sample. T test is used. This test is also used for judging the significance of several statistical measures. It is generally used for testing the significance of a sample mean. F test. F test is based on F distribution and is used to compare the variance of the two independent samples. So F test is mainly based on F distribution and is used to compare the variance of two independent samples. The test is also used in the context of analysis of variance, ANOVA, for judging the significance of more than two samples, sample mean, at one and the same time. Okay, so it is used for analysis of variance, ANOVA, for judging the significance of more than two sample mean at one and the same time. Test statistics, F is calculated and compared with its probable value for accepting or rejecting the null hypothesis. Analysis of variance, ANOVA. The technique of analysis of variance was first devised and developed by R.F. Fisher. When we test the equality between the means of some samples, we can use the F test on the basis of the ratio of two variances for evaluating the variation between samples variation between samples and within samples. Okay. When we test the equality between the remains of some samples, F-test is used on the basis of the ratio of two variances for evaluating the variation between samples and within samples. The technique of analysis of variance can be used for data classified under one way and data classified under two way. Okay, two-way classified data. A given data may be classified on the basis of two different factors. For example, the number of refrigerators sold by 4 salesmen during 4 different months may differ on account of different market conditions and ability of salesman. Okay, number of refrigerators sold by 4 salesmen during 4 consecutive months may differ on account of different market conditions and on account of ability of salesman. Apart from these and sampling fluctuations, there may arise variations in the form of residual variations. In the two-way classified data, the total sum of squares consists of sum of squares between columns plus sum of squares within columns and sum of squares in regard to residual non-parametric tests. Non-parametric tests are applicable to the data based on nominal or ordinal scale of measurement. So we have already discussed different scales. So non-parametric tests are applicable to the data based on nominal or ordinal scale of measurement. As these tests are not based on any specific distribution, they are called distribution free tests. Okay. The application of these tests do not involve tedious calculations as in the case of parametric tests. They save considerable time and provide conclusive justification. Chi-square tests. The chi-square aims at comparing the actual frequencies within each category of a nominal variable against its expected frequency. The chi-square aims at comparing the actual frequencies with each category of a nominal variable against its expected frequency. This technique was developed by Carl Pearson in 1980s. As a widely used technique in all disciplines of study, chi-square analysis tests the null hypothesis that there is no significant difference between observed, that is actual frequencies, and expected frequencies. Chi-square analysis tests the null hypothesis that there is no significant difference between observed or actual frequencies and the expected frequencies. The expected frequencies are calculated on the basis of our theoretical assumptions about the population distribution. The expected frequencies are calculated on the basis of our own theoretical assumptions about the population distribution. Then now we are moving to the next part, interpretation of data. Interpretation is the search for the broader meaning of research findings. The process of explaining the data after analysis is called interpretation of data. So after analysis, the data will be explained. So that is called interpretation. Interpretation simply means drawing of conclusions. A researcher is expected not only to collect and analyze the data, but also to interpret the result of his or her findings. Okay, so a researcher has to collect data as well as analyze data, but he has to interpret the result of his findings, and only the research becomes a worthwhile to the community. Interpretation is essential for the following reasons. Why interpretation is essential? First one, the usefulness or utility of the research findings lie in proper interpretation. The usefulness or utility of research findings depends upon the proper interpretation of the research findings. Only through interpretation can the researcher expose relations and patterns that underline his findings. In the case of hypothesis testing studies, the researcher can arrive at generalizations only through interpretation. What are the precautions required at the time of interpretation? First one, adequacy of data. There should be adequate data, not more, not less. Inadequate data lacks representativeness, while too much of data leads to irrelevance. So, adequate data should be there, not more, not less. Comparative characteristics of the data. The data must possess characteristics on the basis of which comparison between different classes of data may be possible. The data must possess characteristics on the basis of which comparison between different classes of data may be possible. In other words, the data should be homogeneous. Relevance of the data. Here the limits of the data means relevance in relation to conclusions. If the data is not relevant, the conclusions that are based on the data shall be not real and not dependable. Limitations of the data. The researcher must be fully aware of the limitations, if any, of the data collected by him. He must find out whether the data are subject to any limitations. If so, what are the limitations? The researcher should never make any attempt to provide interpretations that go beyond the data. So, only after understanding the limitations of the data, the researcher should make his interpretation. Okay, the researcher should never make any attempt to provide interpretation that go beyond the data. Knowledge of statistics and statistical tools. If the researcher is following statistical method of generalization, a good command over the subject and its use is necessary for proper interpretation. Okay, thank you.